In this video, I'd like to approximate the answer to an equation. And I say approximate the answer because this one cannot be solved in any kind of exact form. There's no formula. It's impossible to find a formula that will solve all 50 great polynomials. That was proven in the year 1820. Very deep mathematics. It's actually related to a 32-sided polyhedron with 22 equilateral triangles and 12 pentagons. That's a long story. Very deep mathematics. But anyway, there is no formula that will give us some kind of exact form answer with fifth roots or fourth roots or cube roots. Nothing like that. But we can approximate the answer by using Newton's method, which would be the normal way to do it. It's actually a simpler method. I think it's called the midpoint rule. If you have a function that you don't know exactly where that root is, well, you can throw in a number and estimate. If that comes out positive, and you throw in this number and it comes out negative, positive, negative, then you take the midpoint, and you've gotten closer to the root. And then you compare these again, and you find that midpoint. And sometimes they're both on the same side. So is that possible? Yeah, you want to choose a side, you keep going back and forth. Anyway, by looking at midpoints, you can get to your answer. It's a rather simple way. It takes a lot of steps. Okay, so I don't teach it. That's why I don't want to dwell on it in this video. But Newton's method works great. The Davidson Carver method works faster. Okay, so going to actually approximate the answer to this. I dropped something. Okay, we're going to approximate the answer to this by using the Davidson Carver method, and I will attempt to show you how I do it on a spreadsheet. All right, now your first step is we're going to need the first derivative and the second derivative. So our first derivative will be 5x to the fourth plus 8x to the third plus 9x to the second plus 8x plus 5. And our second derivative will be, say, 20x to the third plus 24x to the second plus 18x plus 8. All right, now, to solve this problem, using Davidson Carver method, we need a starting point. So I'm going to use x equals -1 as the starting point. Now I worked this problem out years ago, and it's on a sheet that I typed up about the Davidson Carver method, and on it said that this only has one root. There's only one answer to this equation, so we're going to find it. And I just arbitrarily chose x equal -1 as the starting point for this method. Now what do? All right, well, put -1 there. That's my starting point. Plug that in and calculate y prime, and y double prime. So we have to calculate y prime, and y double prime when x equals -1. You get those numbers and you plug it into this formula. Imagine doing this without a calculator, by hand. Oh, what a nightmare. No wonder it never caught on, huh? So, and then when you do all this computation, then you get x2, the next number. I'm sorry, if this is x0, my starting point, when I plug it in and make this computation, I'll get x1. And then we take that number, we plug it all in, we get x2. And we keep cycling around. All right, so as you can imagine, this is pretty complicated. And yeah, that's why I never caught on. Okay, but I like to demonstrate it on a spreadsheet because you could do this on a calculator, and you can program it on a calculator. And I'm not sure I'm going to do a video on that, maybe. But I want to show you the spreadsheet. Now I think most people have Excel, Microsoft Excel, and so let me pull up my spreadsheet. All right, now I'm going to pause the video and reset the camera so it's focused on my spreadsheet. Now I'll wave my hands and talk my way through it. Well, here we go. I've got this set up in my living room with my laptop computer and my camera focused on the Excel spreadsheet. One thing I forgot to mention, when you calculate that Davidson Carver method formula, you have to decide if it's going to be a plus square root or a minus square root. And now for this problem, plus square root worked. So I think it's probably a matter of trial and error. I think there's probably an analytical way to figure that out. And but I think, well, if you don't get a result with the plus square root, try minus square root in that formula. See what happens. Okay. Well, anyway, so let me zoom in a little better here. And sorry, let's see here. Okay. Well, I don't think I can zoom in all that much and show you everything I want to show you. All right, so across the top here, I've got n, which is the steps. So n0 is n equals 0 is the first step. I mean, is the beginning step. And the first step, n equal 1, is actually the first computation. And right here in this cell, I typed in -1 for my starting number. Oh, there goes the air conditioner. Hope that sounds not distracting. All right, so -1 is the starting point. And over here, whoops. Oh boy, I messed that up. All right, there we go. Here I've got the function y. Now I typed in, and I hope you can read it. I have equals b4 caret 5. Okay, so b4 is this cell right here. Think of that as x. And so when I type in equals b4 raised to the 5th power, that's x raised to the 5th, and then I plus 2 times. For multiplication, you have to use the asterisk symbol. 2 asterisk means 2 times that cell, and you can click on that cell normally, or you can type it in b4 raised to the 4th power plus 3 b4 to the 3rd power, and so on. That's the function for which we're finding the root. Now when I go over to here, I have something similar, except this is the first derivative. Equals 5b4 to the 4th. Again, b4 is the starting number x. And there's the first derivative, and then the second derivative is typed in here. All right. Now the big moment comes when I come down to this cell right here. And that cell is the Davidson Carver method. Okay, that's the formula. And here I've got plus square root. I found if I put minus square root, I don't get an answer. I just get error messages. Probably it's giving me square roots of negative numbers, and it doesn't like that because those are complex numbers. All right, so on the first round of the Davidson Carver method, that parabola, so we have this function, we fit a tangent parabola just touching the graph at x equals -1, and we follow the parabola down, and it crosses the x-axis at -1.618033989. All right, so that's our first computation. That's presumably going to get us close to the answer. And so now from here, I literally just, for example, these 3 cells, I just dragged it down like this. And uh-oh, something happened. What happened? Is that right? Hang on. Oh, yeah, that was correct. All right, so I had, let me show you what I had before I got going on this. Oops. All right, before I really got moving, all this was blank. All right, fill. There's also a fill symbol up here, right? I'm working on a Macintosh. It might be a little, and this is an old version of Excel. This might look a little different on a PC or on a newer version, even for Macintosh. All right, so these are the numbers. I had to type these numbers in, and then the Davidson Carver method is here. Now, from here, it's automated because I'm going to take these rows and fill them down. So that's the automatic fill. You can also do it this way. I have to do the same thing with this cell also. If I highlight all those cells, go up to fill. I want fill down. There we go. And there we go. It gave me the answer right here on the fourth step. Negative 1.491797988, something like that. That's correct to, accurate to 9 decimal places, I believe. Okay, now we could go more or less decimal places depending on what you want to do. Notice that now the computer is storing more decimal places. I don't know how many places a Excel stores. It's a lot. It's more than my calculator. And when it plugs it into the function, it thinks the answer is 0. Okay, now this is not an exact answer, but it's for all practical purposes. Excel says, oh, that's 0, because it's below a tolerance value. All right, so we have an answer, a root to this equation, in 4 steps, and that's how that went. Now, let me go over to here. Oops, I gotta loosen the camera so I can spin it. Here it is with Newton's method. Now, we had this answer in, my finger's off camera, we had this answer in 4 steps, the Davidson Carver method. Newton's method, it required, for that accuracy, required 7 steps. 7 steps before we got the answer. So it's 4 steps versus 7 steps. And so Davidson Carver method really was faster. It saved 3 steps. Now, what would I use? I would use Newton's method, a lot easier. And up here, it's the spreadsheet's similar. I'm going to make the spreadsheet available on my website. The x's, it's set up very similarly, except I don't need the second derivative. And this computation right here in this cell is Newton's method, which is a lot easier, because Newton's method is x minus y divided by y prime. Okay, and so it's a lot quicker in terms of if you had to actually calculate it yourself. Now in a spreadsheet, it doesn't matter. These things are so fast. Just setting up is a little more work, isn't it? It's a little more complicated. But Davidson Carver methods is faster than Newton's method. It's in numerical analysis. It's a study of computation. The Newton's method has a quadratic convergence rate, and Davidson Carver method would have a cubic convergence rate. So what's that mean? All right, now this took 7 steps. 7 squared, quadratic, 7 squared is 49. Over here, Davidson Carver took 4. 4 to the 3rd power is 64. Now, 49 and 64 are kind of apart, but that's roughly the ballpark. You can calculate how many steps each would take. If you know how many steps, say, Newton's method took, you could estimate about how many steps Davidson Carver method would take. So what would that be? It would be 7 raised to the 2/3 power, I think, something like that. Anyway, so there we go. There's the spreadsheet method. This can be done on calculators. And I'm sitting here waving my hands at in front of the Davidson Carver method, and the camera's not pointed over there. All this can be done with on a calculator, programmable calculator, and or if you understand the spreadsheet, it's fantastic. Spreadsheets are amazing devices. The first spreadsheet was called, I believe, it was called Lotus 123, something like that, or maybe it was just called Lotus. I forgot exactly what it was called. It came out maybe in the mid-1980s. Maybe a little bit earlier, and eventually got superseded by Excel, which is by far the most popular spreadsheet. Apple Macintosh has a spreadsheet called Numbers, and it's about the only program Apple's done I think is actually inferior to Microsoft's. Okay, so Microsoft does a great job with Excel, and but when I was learning Newton's method, we didn't have computers. We didn't have, well, there were computers, but we didn't have our own personal computers because they weren't in existence back in the 1970s. And so we had to do Newton's method by hand, and which was a lot of work. Okay, no, I take that back. We did have calculators by the time I took calculus. most of us had calculators, but still a lot of work. All right, well, I'll quit jabbering here. I will make this spreadsheet available on my website for Calculus 1, and there you go. That's the comparison between these two methods. And just one other thing. Faster method in terms of convergence rate, slower in terms of complexity. That's the trade-off, and that's a pretty normal thing. Okay, well, that's it for the Davidson Carver method.